As other things, just in case somebody decides to send me the great grand secrets while I'm sharing my screen here. So,
And letting everyone know we are recording now.
yes,
Thank
yes.
you.
Yeah. Thank you so much, Kim. All right. So let me see if I can manage both the screen share. Let's see.
By the way, David,
Uh,
you can share a screen from CubesOS if you do a tab sharing.
Oh,
So
really?
yeah, if you Chrome, and Chrome can do just share tab and meet. So that's how I used to do it.
Oh, I'll have to send you an email. I wanna learn how to do that.
Okay.
all righty. Okay. So, in theory, we can all see your screen, see your slides. Can someone else confirm to me that this is
I
Yeah.
can
working?
see him.
Very good, David. Thank you.
All right.
All
I
right.
know how to push buttons. Excellent.
Great. So I just wanted, before I dive into this, I wanted to point out that this is a bit of a hybrid presentation. The first few slides is basically about the history of this project. I ran 2 mentorships under Hyperledger for the last 2 summers with 2 different mentors. We tried a number of different solutions, did a lot of research. Constantine's feedback, although indirect, was crucial to getting to where we are right now. So I'm going to run through like the first, I don't know, 10 slides or so pretty quickly. Just know that summer of 2019 and summer of 2020, we had student mentors that tried a bunch of things, right? So next slide. So the goals when we started was to modify Git to give it the ability to sign and verify signatures of any kind, right? Not just GPG. And as a secondary goal, what we wanted to do was normalize the command line switches and configuration setup for handling signing and verifying, because there's a lot of legacy, dash GPG this and GPG that in both the command line and configuration. So we're going to absolutely maintain backwards compatibility. That's just a hard requirement always. So if you had existing tooling and you were using the old config values or the old command line switches, that it would still work, but it would assume same defaults, right? So GPG would always be one of the options, and if you use dash GPG sign, it would configure Git as if you had used the new system and defined GPG. All right, next slide. So our approach was to abstract away. So this was our first approach. Okay, 2 summers ago, we wanted to abstract away the signing infrastructure so that it was sort of driver. It was like a driver model, right? We had it's kind of like what the kernel does, right? You had a struct with function pointers, then we had implementations of that struct with concrete functions for each of the methods. We succeeded in doing a lot of cleanup around the config switches and the command line switches and the config settings. And we wanted to make the signatures self-describing in the sense that they would identify what signing tool they used and what tool. So then Git could infer what tool to use and all those things. Okay. And then as far as preserving backward compatibility, we converted the existing code for GPG-SM and GPG into drivers that followed this thing, this new abstraction. Next slide. So I think you guys all kind of know how this works, how signing works, right? It pipe forks to GPG. It's hard coded. It uses standard in and standard out to pipe the contents that needs to be signed to GPG. It signs it. The signature is sent back to Git over the standard out pipe, or sorry, the Git's standard in, GPG's standard out. And then any error failure is represented in the exit code and standard error messages, right? And then there's some really, well, let's see, I don't want to judge it because it was done and it works, but it hard codes hand parser for looking for GPG sig lines and things like that, or sorry, messages in the standard error log to decide whether it worked or not, right? Okay, next slide. Verification, same kind of thing. It uses string matching functions to detect the signature that's in the get object, extract it, stores it in a temporary file, then pipe forks to GPG's verify command. And then, oh wait, I'm sorry, I made a mistake. It's the verification that has the hand-coded parser for the phrase, good sig, the string good sig, to determine if the signature was good or not. So it works, but there's kind of a breakdown around that in terms of the signature parsing and stuff like that. So if GPG changes its error messages for any reason, it would break its integration with Git because it's hard-coded. Okay, next slide. So yeah, in 2019, the mentor's name was Ibrahim. He was great. We did succeed in abstract. So next slide. We did. I'm sorry, my dog.
And this was your second approach, right?
No, this was the first approach, Ibrahim.
Oh, this is
right?
still, so we're still on approach 1. Okay.
Right. So this was abstracting away into the drivers. Okay. So, and then the point here is at the bottom, those are actually live links to the submissions to the mailing list that contained his patch set. And most of this is usable and probably should land with whatever happens in the future. Because patches 1, 2, and 3, I believe, clean up and normalize the command line switches and the configuration stuff. All right, next slide. This was just a picture that he gave in his presentation. Again, we abstract out a generic signing interface and had drivers for each of the different signing tools. Next slide. We cleaned up config so it looked something like this, right? Now, we later found out through research that this was not sufficient, and I'll explain that later. But we tried for simplicity, but it needs to be a little more complicated than this. All right, next slide. So then 2020, we had another project with Jimit. Oh yeah, sorry. Before I move on to the 2020, the result of the submission to the Git mailing list was we don't want to have drivers written in C because of the fear of an explosion, a Cambrian explosion of C code that would have to be vetted because this is the signing infrastructure. It would require extra security checks and extra maintenance. And they were afraid of, orphaned C code, right? Which is a lot harder to deal with than orphaned external scripts, for instance. Let me stop there. Is there any questions about the 2019 project?
Just a comment that good sig is actually what you're supposed to do. Look for that in brackets. Good sig.
Good sig with brackets.
Yeah. That's if that breaks, then basically everything breaks. So that's
right.
It's supposed to never break.
Right. Okay. So moving on to 2020, we had Jimit. Jimit picked up the existing patches, spent a long time trying to understand it, going through all of the mailing list feedback, working with several of the key maintainers in the Git project, trying to negotiate, okay, we can't do drivers. What are our options? So next slide, please. What are our options? Which one should we push forward on? And then that took long enough that in the end, what Jimit ended up doing was working closely with me to come up with a proposal. And that's what's the rest of this slide deck. Okay. And of course, Constantine's feedback and a couple of one of your blog posts about carving commits into sig chains or something like that also influenced the thinking here. So thanks, Constantine. So initially we wanted to try to standardize the pipe fork interface and then write, basically we would accept the GPG pipe fork interface that's hard coded as the de facto standard for talking to external tools. And we were going to write bash scripts essentially that would mimic GPG's behavior, but for other signing tools. We tried to do this. We went down and we did some initial investigation, but figured out that the config complication just became crazy. Trying to do all these really long command lines and stuff made maintenance of the config file unwieldy because, it would deal with a lot of legacy compilation or complications of signing tools. So then we looked for other options and we did a big survey of different signing tools. And the one we landed on is how GPG handles coordinating between the pieces in their ecosystem. GPG ME uses, I don't know how you pronounce this, but the Azuan protocol, I guess. which is a very simple line-based, text-based protocol for coordinating things between like agents and key enclaves and things like that. And when we looked at it, it's very clean, very easy, and it meets our minimum requirements for Git to talk to any signing tool. And what's cool about this is we can design it in such a way that we can support Konstantin's concerns around mail, like digitally signed mail-in patches, emailed patches. So we did a lot of research and basically said, look, there's a small set of fundamental problems, okay? GPG has to be able to identify what needs to be digitally signed and with what identity, okay? Now it already knows how to identify what needs to be signed, but identifying the identity of the signing key or the signer is hard-coded right now as name and email because that's what GPG uses, but we can turn that into a generalized string so that it identifies the signing key for any arbitrary signing tool. So that's solved. Okay, then the data needs to be sent to the signing tool to be signed, and then the result needs to be read back. So the resulting signature needs to be read back, and the success or failure. Okay, now the As-You-Want protocol solves that. It's very clean. Okay, now what comes back from the signing tool has to be a signature and then any metadata necessary for verification. Because what we're trying to do is make a digitally signed or like a Git repo that has digital signatures in it to be self-verifying in a way. So every digitally signed object needs to say, well, okay, I was digitally signed with this tool, with this identity, and these are the options that need to be passed to a verifying tool, along with the signature, along with the identity, for the verification tool to do its job. So we have to transmit data through time, essentially. And again, the As-You-Want protocol supports this. And then the other problem for verification is, like I said, you have to send the signature, the data that was signed, the identity of the signer, plus the options needed for that particular signing tool. And it's the options that are the key to making Konstantin's concerns, his requirements, something we can meet with this design. Okay, I'm going to pause there. Any questions at this point before we dive into some examples?
Constantine, is that your requirements, the link that you posted? Is that what you're referring to?
That's the description of what we're trying to accomplish, basically. It's
Yeah.
a way to attest the patches outside of Git, so that before they actually make it into the Git repository, how do we make sure that patches are not modified, or else we get able to give attestation to developers.
Right.
Got it.
Right, and I will get to a very specific example that I think meets Konstantin's requirements, because he's proposing using Minisig, which is a different signing tool, but and then with the limitations of email submission, right? I think we can meet his requirements. Okay, so next slide. The config simplification for a protocol-based approach looks something like this, where you have section in these names are arbitrary. I just picked SIGs because it was short and easy, and then subsections for each tool. There are different ways of doing this. So you can have a program that literally calls an executable that will be pipe forked that understands the As-You-Want protocol on standard in, standard out, and standard error. Okay. And then the options section is just, the identity, the default identity of the signer, and then any options related to verification or the generation of the signature and the verification of the signature. And I'll show you how these are handled. But these are fairly freeform, the options, and they're passed through to the signing and verification tools verbatim. Now, the ones in the config or from the command line get passed verbatim to the signing tool. Then the signing tool is responsible for passing back options that will get stored in the signed object that will then later be passed verbatim to the verification tool. And that's how we connect the dots, okay? And I wanted to highlight here in the config that you can have a single tool that handles both signing and verification, as in the example of OpenPGP. You can have separate tools for sign and verify, as in the example of OpenSSL. And then you can even use, if you had a server that speaks the AS1 protocol that's over a socket or something, like in the X509 example here, I'm just using SOCAT with standard IO doing an open SSL, so doing an SSL connection to that IP address and that port, passing those parameters to say like an external X509 HSM. This is how this is done in like banking systems and existing, you know, certificate authorities and things like that. They have hardware HSMs that are only accessible over the internet, over the network, and they have to use like TLS connections. And so the cert there is the client cert to use over the TLS connection for authentication and authorization. And then the option obviously is saying, hey, go ahead and use the, like, say, the Hyperledger's TLS certificate to sign the data object. Okay, next slide. So for the protocol-based approach, I've already covered most of this. It will grab the configuration from the command line or the config, it pipe forks the command, and then uses standard in, standard out, and standard error. From the standpoint of client server, Git is the client, the signing tool is the server. It uses options to pass those options from the config and command line to the signing tool, uses the sign command. Okay, let's go to the next slide here. I'll give you a better, I think that the protocol will give you a better understanding here. So lines that start with S : are the server, which is the signing tool in this case. C : is the client, which is Git in this case. So Git would pipe fork, and that upon execution of the signing tool, to signal that it was ready, it would send OK to Git. Okay. And then Git says, okay, here are my options. And it's doing all the options from the config line. So this is using GPG. This is an example of using GPG. And if you remember from the config, these were the options there. It says, hey, here's the identity of the signer. Here's the min trust level, this is for backwards compatibility, by the way. Git supports this already as a command line switch. So that's why it's here in this example. And then the hard coding of GPG at the moment causes ASCII armored detached signatures to be generated. So this is the default options for GPG in this new system to support backwards compatibility with existing signatures. Okay, so after doing all of those options, the server's confirming okay for each one. Git then issues sign command, and then it issues D lines, which are the lines of the data to be signed. And there's a maximum number of characters, and I don't believe there's any encoding necessary. It can just, you know, verbatim, line after line after line.
So how does it handle signing of binary data here?
Oh, I think you do base 64 encoding, I think is the AS1 standard for binary.
Okay. But there is a convention for it.
There is a convention for passing binary data, yeah. Because GPG does this, right? It passes blobs between different tools over the AS1 protocol. Okay, so then when it's done with sending all the data lines, it sends an end command, which tells the signing tool, okay, that's all the data. You have all your options. Go ahead and sign it. The server then replies immediately. So the signing tool replies immediately with data lines, and it starts with the options that need to be the options that need to be stored in the signed object along with the signature itself. And the idea here is that these lines will get stored verbatim in the Git object. So these make the signatures self-describing. SIG type, it's an OpenPGP signature. SIG options is the list, comma-separated list of options that must be passed to the verification tool. And then the SIG lines are the lines of the signature data. This is very close to how it works already, except we don't have self-describing and don't have options. So that would be something new. And then after the signature was done, or it was done sending the signature, it says, okay, the client Git says bye, the server says okay, and then the signing tool will exit. You'll get an exit return on whether it succeeded or failed. And at that point, you would be able to take the replies and parse them and show an error or something. So if you get a return code that's less than, or that's greater than 0 or not 0, I mean, then you'll have received error lines in the protocol that you could then display to the user. The AS1 protocol will reply with E lines with error codes if there are errors. Okay, next slide. Verification. basically Git parses the sig type options and sig key. It pipe forks, it takes the config switches and the command line switches to figure out what command to run for verification based on the type of signature. And then it pipe forks, passes options from the sign tool, and passes if there's a sig key, it will pass the key directly. Otherwise, it does the identification and then does the signature and verify and passes the data. So here, let me show you an example of that. So the verification of the signature, next slide, please. The verification of the signature that we just created, similar, right? S is the server, which is the verification tool, in this case, GPG. C is Git, the client. It's going to pass those options that were stored in the Git object. So min trust level equals marginal, passes those verbatim to the verification tool. Then it passes the signature lines, which it pulled out because those were the sig lines stored in the object. And then it issues the verify command, which is the lines of data, the D lines containing the data of the signed object. And then the server will reply with either D lines or E lines, okay? And D lines will be its message, its verification message if it's successful. E lines will be the error associated with the signature. So if the signature doesn't check out, or it was done with an expired key or anything like that, you would get E lines. And then again, we have the okay, bye, okay, right? So let's go on and look at something a little more interesting. This is where, go to the next slide, please. So Constantine wanted to, and correct me if I'm wrong, Constantine, okay? You want to have email submitted patches that were signed using minisig, which produces very small compact signatures. And you potentially also want to link, because minisig supports having verified comments. I am proposing here that we link the signed off by line that comes along with the patch to the digital signature when they're created. So let's say I want to submit a patch to the kernel project and I want to digitally sign that patch that I'm going to email. My Git would do something like this. It would connect to the mini sign tool, and in my config, my Git config, I would have, hey, here's my signing key, right? And there's the path, home user, minisign.key. So that gets passed to minisign. And then the next option is, hey, use this regular expression to extract a string from the data that is being signed and make that part of the cryptographically verified comment that's associated with the minisign signature. This is a feature peculiar to minisign. And so in this case, that the verified comment regular expression is to extract the signed off by line. Okay. So then my Git client, Git tool would issue the sign, and this would be part of, say, like Git format patch, for instance, right? So it would be giving the lines of the formatted patch as it would be put into an email, as it would be wrapped as an RC 722 message, an email message. And what we get back is, again, the sig type line that identifies this as a minisig or minisign signature. The sig key in this case is the public key needed to verify the signature, because minisign doesn't use a complicated signer identification. They're just like, give us the public key or the key pair to sign or verify. Okay, so in this case, we would be putting the public key of the signer into the signed object, and then the signature itself would also go directly into the object, and then you get the okay by okay. Okay, I'm going to pause there. Any questions so far?
Well, I mean, you're putting this into the Git object, right? So, but
well, in this case, it would be in the email, right? That's
okay.
being formatted. Yeah.
All right. So the one that you're linking up is like the version 1 of the proposal that I have, and the one I put in the chat is the version 2.
Oh,
there is a significant difference between them, because the version 1 did just basically fail to adopt, because I was trying to be too polite and saying, let's not bloat the headers of the emails and have external documents for verifying patches.
yeah.
And for everybody else, it was basically it failed to take off. So the version 2, we said, fine, you want to bloat the headers, so we're putting all the attestation information into the header of the email. And that the biggest problem with preserving signatures from between Git and email and then Git again, right? So currently the way it happens is somebody writes code, they commit it to their local Git repository, then they do Git format patch, and they send it off to the maintainer to look over. But we cannot directly translate that back into a Git object, because almost always, 99.9% of the time, the maintainers of the project will want to add things to the commit message or to the sign off, reviewed by, signed off by, and all that stuff. So that's where this breaks down, because I had the same idea. Can we preserve Git commit information through the entirety of this process, between Git, then to email, then back to Git? And the response to this was that this is, one, not possible, and two, not needed. Nobody wants this, because this creates the problem for them that they can no longer modify the commit message or make slight minor changes to the code, like for line breaks or for any other kind of minute changes. Everything would require them. I found this tiny error or missing semicolon or bad formatting, please resubmit. And that just creates too much back and forth. Nobody was really interested in that. So what we're trying now to accomplish is say, okay, so we're not going to preserve this through the Git object completely through email. What we want to do is just provide the link to based on the message ID to where somebody can look at the entirety of the message and then do whatever attestation verification that they want to do. And when the maintainer, when they receive the patch, they will be able to run local verification just to make sure that at this stage they can verify that this was submitted by the developer or the domain of the developer, and that's all the information that they want. And this is actually fairly successful right now, largely because we are sort of falling back to DKIM for larger chunks of this.
Gotcha. So you're pulling public keys from the domain, their DNS server and stuff.
Not even that. Yeah, well, we're pulling public keys from the DKIM record. So almost all email these days is DKIM signed. DKIM is not fantastic for this, because it does some normalization that actually breaks stuff like Python, right? You can submit the same to different patches. They can have the same hash, because all the white space would be collapsed into one. You can imagine that for Python, for example, a return that's indented versus a return that's unindented can have a completely different meaning. Right?
Yeah.
And there could be a security problem. But but if somebody wanted to submit a GPG or any other kind of signatures, they are able to do so. And the link that I provided there, we look into each of the scenarios there. We can say we can sign this directly with DKIM. We can sign this with PGP, we can sign it with Minisign, and we can sign basically with anything that we want, as long as we actually specify which one it is in the headers of the message. But we don't try to preserve this between Git and mailing list and Git. So the objects will almost always be broken. So we don't want to go down that route.
Okay, so maybe I don't want to go down this road since this is based on old information, but that still doesn't modify the desire to normalize the interface between Git and external signing and authentication or verification tools.
Yeah, for sure. No, this is correct. Being able to, for example, sign with Minisign or sign with any other signature mechanism would be much better than just having GPGSM or OpenPGP, because Minisign, the upside of this is that it is much simpler, and there are ways of distributing public keys via like DNS records, because the key is tiny enough to do this.
That's correct. Yeah. So anyway, I think that's the end of my presentation. I do want to follow up with you, Konstantin, and see what you proposed in your second email and see where the community is at right now, to see if there is anything that would modify this design. This is just a proposal to be able to teach Git how to talk to any verifying signing tool in a standardized way, and then be largely agnostic to what comes back from the signing tool, stored in the object, and then what it passes to the verification tool. So this is basically hacking Git into being the tool that transmits signatures and the associated metadata through time to the verifier, right? And it just has a standard abstracted interface. So then any signing tool that wants to be used by Git just has to adhere to this very basic, very easy to implement protocol, and can be easily integrated into infrastructure. I think one of the strong selling points here is being able to use external HSMs. I know the Google FIDO team was very interested in this. And so like the example in slide 12 of doing a SOCAT, TLS connection over to an HSM, that's a pretty hacky way of doing it, but it accomplishes kind of what I've gotten from industry feedback.
Okay.
Hyperledger.
Okay.
So I was going to say one last thing. Hyperledger's interest here is that we are moving towards self-sovereign identity, which is decentralized digital identity. And there have been proposals to use Git, well, written by myself, to be honest, to use Git repos as the PKI mechanism, and to make Git repos fully self-verifying. So the records, the provenance of digital identities and signing keys is tracked in the Git repo itself using files or metadata or anything like that. That's totally separate thing. But the first step is we should teach Git how to use any signing tool, because there's significant desire for this across industry for many different reasons. Hyperledger is just one. Google has their own. GitLab has their own ideas. The LF actually has their own ideas. We want to be able to track the provenance of using digital signatures to do DCO and CLA tracking of contributions. So anyway, I'll end it there and take questions.
Yeah, so I have two, although I can take turns. So I had one just in general about the ASWAN protocol. Do you have a URL? Is that, I presume it's written somewhere? Is there what's the license of that, or is there some legal issues we need to be worried about?
It's in GPG-ME already. I don't know what the license is. Whatever governs GPG-ME. It's hosted on GNU-PG. Let's see here. It's published by the Free Software Foundation. Here, I can post the link real quick in the chat of the documentation. We should do some investigation. If this doesn't work, right, for some reason, licensing or whatever, I just propose we develop our own protocol and release it under Apache 2 at the LF or whatever. Or as part of the Git project. Just say I think what I want to do is get agreement with the Git maintainers and industry people with interest that we should have a standard, simple protocol that Git uses to talk to external tools for signing and verifying. What that is and how it manifests itself, that's up for implementation details. I just proposed this one because it was already used in cryptographic contexts and has pretty wide support. Yeah, there you go. Thanks, Konstantin.
Oops. So it's posters. It's
right.
posted in the chat.
Yeah, Konstantin beat me to it.
Yeah, in general, I will say for your mods to Git, the general policy, at least the OpenSSF. Original technical charter. And I think what people generally do anyway for all of things is, if we're contributing to an existing project like Git, then whatever that license is, as long as it's an open source license, go. Because otherwise there's no point in making code that won't be accepted because of licensing issues.
Mm-hmm. So far, no code has been written other than the first 3 patches from Ibrahim's patch set 2 summers ago. That largely does the yeoman's work of cleaning up the config and the command line switches. The code that normalizes the signing interface that's in patch 4, I think, is a good jumping off point for cleaning up the signing interface and making it use a protocol rather than the hard-coded pipe forking to GPG. So I would guess that about 75% of this proposal is already implemented, and that someone working full-time could easily do it in 2 weeks and have full test suite, everything passing.
So libasso in itself is new GPL v3, but that's the library and not the protocol. I'm not sure there is a separate license on the protocol or how the library license would, be applicable to the protocol itself or not. But it's v3, so theoretically a protocol is covered by it as well. I don't actually remember how that's handled.
Yeah, I wouldn't assume that actually. I mean,
Okay.
the protocols are their own beasts, and you can even say that the text about the protocol is licensed, but that doesn't mean that the protocol is licensed.
Mhm.
And
Right.
full disclaimer, not a lawyer.
Well, that's why we have a legal department, right? But,
That's right.
yeah, I have a comment about the submissions because I think they were fairly well received by the Git community, but the fact that it's coming from an intern or somebody who says, I'm just a student working on a summer project code, I think that gives it sort of a amateurish patina, if you like. I think it needs to come from a more solid group saying, we would like this implemented for the following reasons.
Right. So there is explicit support from the Google Fido team. I've talked to a number of them. We've had several meetings. They want to use this for obviously their external signing hardware and infrastructure. And yeah, I mean, me as a Hyperledger employee, we have industry partners like IBM and SecureKey who have interest in this as well. So at this point, you're right. It really just needs to have some broader industry buy-in for whatever reason, right? It doesn't really matter what their reasons are. If Google says, yes, we'd like this, we'd use it. And if IBM says, yes, we'd like this, we'd use it. I think it would stand a good chance, especially if it got a lot of scrutiny and we went through the process of, whatever the future process, right? Where it's a proposed addition, you can compile Git with the support, we can test it out in industry and maintain it until everybody's like, yeah, we think we worked out all the kinks, and then merge it upstream to the main branch. So I've already worked 2 years on this with interns, so I'm good for another 2 years, I think.
Well, I don't think we want you to take 2 years.
I've been trying to convince Brian to just let me take 2 paid weeks that don't count against my vacation. Let me code this up and float it in front of the Fido team and the teams over at IBM. But currently, I'm personally Thursday is my last day at Hyperledger and at the Linux Foundation. I'm moving on to take some time off to take care of family. My father's passing away. He's dying of dementia. My mom needs help. They're elderly. And so I'm going to take an indefinite period to take care of my parents. But I will be on email, and I can still come to meetings. I would still be very much interested in being part of this and shepherding it through. I don't know that I have time to write the code though.
Sorry to hear that, David. But thanks for your.
Oh man, yeah, I'm very sad to hear that.
Well, I mean, the full story, you guys. I seem very flippant, but my dad had a really bad head injury when I was 11. He had a job site accident, and I was told by doctors that day that he wouldn't make it through the night, and so I'm thankful to have had him for the last 30 years, actually. So. I've come full circle, right? Death is part of life, and I love my dad, and I just want to spend time with him in his last days.
Yeah,
Full time.
Do you have maybe offline you can tell me who on the Google Fido team you've been working with, so maybe I can follow up. And I mean, I think a lot of us want to see this implemented. It seems like you need to take some time off, so I'm curious if you have other folks in mind that might be able to do the work.
No, I'm still able to propose. You guys aren't gonna like this. I'm still able to propose Hyperledger mentorships as part of, as being an alum and part of the Hyperledger community. So, I could sponsor one and mentor somebody this summer that could do the right, be my hands. But I don't know. I just can't promise it. I've been trying to just say, look, I'll sit down and write the code, right? I've been a C and C++ programmer for 20 years, and it's not a very difficult task for someone like me to do. It's just it's impossible for me to get 2 weeks where I don't have to worry about anything else.
Sure. I think among this community, we can probably put some heads together and figure it out. Maybe I can put some pressure on some Google engineers or something. I don't know.
Right. Let's talk to the Google Fido team and see if they've got, somebody who's new that needs a project to work on.
I mean, it sounds like the Git maintainers are receptive to this work. They just want to see that, there's people behind it that are interested. Is that?
Yeah. There's a significant community in the decentralized identity world that wants this. And I know that there's a lot of people who want to build self-verifying Git repos. I've talked to several people at GitLab that want to build that into their tool chain so that you can clone a repo and it can immediately go, yep, that whole thing is verified. You have the canonical version, the maintainers stand behind it, right? Everything checks out before you even try to build anything. It's part of, that's why we're here. It's open SSF, right? Yeah.
On that note, David, have you thought much about downgrade attacks on these self-verifying objects?
Can you?
But I need a little more. I mean, I know
okay.
I know what you mean by downgrade attacks, but give me some more sauce on that.
I mean, as soon as you started talking about like, hey, you can pass options into the signing process, and then those options will be signed over and contained in the object to be used for verification. So like a classic example of this is, one that got a lot of attention anyways was with the JOTs, JSON Web Tokens, where the same sort of thing happened. You'd pass in headers, and those headers would be used to configure the verification mechanism. One of the headers was the algorithm that you were using, which means you could downgrade the quality of the hash algorithm from, say, like a strong SHA algorithm to, say, MD5. And then to make matters much worse, they then later added as an option algorithm none, which meant there was just no signature at all. So someone could then take a JOT library and rip the signature out, put alg none in there, and it's going to verify on a naive verifier.
Right. So the way you do this is that any inputs to a verification tool have to be covered by the signature. So any modification of that would cause the signature to fail, regardless of any potential downgrades, right? So you would pass the options through. So if you go back to slide, let's see, what slide is it? Slide 16, if you can.
Yeah, hold up. I got to actually share again. So I was trying to take notes as we were going and run out of hands.
Right. So in slide 16.
16.
Right. You could see that. I'll wait for you, David. So if you look on, so it's passing option min trust level equals marginal. That line trimmed. So everything missed, like option space, right, would be trimmed off, and anything after marginal would be trimmed off. That could be seen as the first line of the data that is being verified. Okay. The reason they're in this order is because it makes sense to someone debugging it. But what you're really doing is that's the first D line that would normally appear after verify. Now, if we wanted to normalize this, we would just put, okay, signature, D lines of the signature, then verify. And the first D line of verify would be min trust level equals marginal. And then the lines of the signed data object, so that the signature itself covers the option, includes the options used for verification. So if you do that, then you're immune to downgrade attacks in this way, because the configuration of the verification of the verifying tool itself is tamper evident, right?
Well,
if it gets modified, then the signature just fails.
Yeah.
Right?
Unless the options affect the quality of the signature. Right. Like if you can modify the options to a low quality signature that you can then spoof, then you could still forge a signature over, like if you could change, if one of the options was the signature algorithm and you changed it to MD5 and found a collision, as not a cryptographer, I guess. wondering, like this stuff is subtle.
Well, it's also
Yes.
part of it's also part of the git commit, so it will also be hashed, and the next,
Mm.
I mean, the chain would then be broken. You can't modify the previous any of the options in the
Mm.
previous commits, right? So there'll be then your Git repository will start being valid.
Mhm.
You could theoretically modify the latest at the tip commit because that's not stored in the next commit yet. But then you can also modify any other part of the Git commit, right? Then it's kind of if we're talking within the constructs of Git repositories, then this is already going to be tamper evident if you modify any part of the commit object.
Right. So the object hash is sort of a second factor. I mean, what you describe is theoretically possible. I'd have to dig through it. But digital signatures are not necessarily reliant on a hash. I mean, when you specify a hashing algorithm in a digital signature, you're not using modern digital signatures because they don't do that. They use sponge functions. So Kachak and all the other ones, they're not encrypting a hash anymore. So, and I think it's in response to things like what you're describing, actually. So if we're using modern signature algorithms and the configuration of the verifying tool is covered by that signature, I mean, anything's possible. I won't ever say anything's perfectly secure, but I think that's probably good enough. Because existing systems already do this, and they seem to think it's good enough. Things like Secure Scuttlebutt does stuff like this, where the configuration of the verification is either hard-coded in the tool or is covered by the signature. So, and other secure systems like the TLS handshake protocol does very similar too. It's signed for offers and acceptance of protocol negotiation. So, that's really great. That's awesome feedback. I love that you're thinking that way because, I'm just one engineer and I love having someone look over my shoulder and pointing holes like that. I think what we should do is I would love to just try to do a quick and dirty implementation of this and just start iterating, do an early release and start iterating, maybe set up a sub branch in the Git repo under the future or whatever it is. What's Git's mechanism where they have there's like a whole branch of potential upgrades, like when that's how they handled the SHA-256 upgrade.
It's next, I believe.
Next, yeah. Like start doing a topic under the next branch for this, I think would be great. That would probably be a good way to manage this. So
this is a smaller point, but I think I've mentioned to before, David, but just a quick note on the larger group. One challenge with the Git configs as you were showing them is, most people, what they want to do is they want to install software with package managers and not muck around with their config files to make things work. I think this would be easily handled by also teaching the Git program to look for a global directory, slash like on a Unix-like system slash etc slash dot slash git config d, and
right.
then all the configs in there. And that what that would mean is instead of constantly trying to edit a config file, which is kind of risky, when a package gets installed, it just installs, oh, here's another way to sign packages, and here's the configuration of how do you do that with Git. And so once you install the program, presuming Git's been taught this other stuff, Git will quietly and automatically know how to use that tool
That
without
is
Git developers having to do anything.
right. That's an awesome upgrade, and I don't know why Git doesn't support this already. I see that as a parallel effort or a tangential effort, something that's not directly a dependent of this upgrade. But I think you're right. That would make it really awesome if it supported a git config.d or whatever, or git config.d
Right.
directory. That way, I can install the package for minisig and it can have a contrib package that has git configs that just drop in into place, right? For how to
Exactly.
run the tool. That is awesome. And maybe that should be part of this project, but I don't think this project's not dependent on that.
It's not dependent on it, but I think this is part of this overall, not just this group, but all the OpenSSF working groups.
Right.
I think we keep talking about not just making security possible, but making it as much as we can easy or the default.
Right.
Because the all you have to do is edit a configuration file. You already lost 90% of the people.
That's true. That's true.
Every extra step is a disaster as far as I'm concerned. Every time we make it easier is, make it that quote easy button, we're more likely to actually get people to do it.
That's true. Yeah, and the interactive package install stuff could be wizards, right? So like a dpackage reconfigure, minisig git or git mini sign, right, would walk you through, generating a key pair and pointing
Right.
the path, and then it
Or just
generates
the first
right.
time you sign it, oh, wait a minute, I don't see your key. Would you like to make one?
Yeah, exactly.
But exactly. I think that's exactly the way we need to be thinking: is how can we make it so that there's as close as we can, zero pain, as automated as possible. We're never going to make everything automatic, but the closer we can, the better it is.
Right. Right.
Well, the hard part is not making a signature. The hard part is telling everybody that this is your identity and why they should trust it, right?
Right.
That's fair. But I think my point still stands. The easier we can make it, the better it is. And including that part, how do I get that word out that this is the key I'm using?
Well, this is
So-
the DID get stuff, right, that you were working on, David.
Right, exactly. So I don't want to dig into that because I think there's modifications that need to be done. I think the DID method crap is overly complicated. I think the W3C came in and said it's a web technology and overcomplicated everything. But, as they tend to do. The one thing that came out of that research and that work, though, that's really, really interesting to me is that contributions to open source projects digitally signed and stored in a Git repo is the only way I know of for there to be a human scale proof of work. And if you can get a human scale proof of work, then you can also have a solution for trusted anonymous digital identities that are Sybil attack proof. So I could be, a Git developer that has published my keys like in the Git repo, like in some folder, like, hey, here's my signing key. And you can just call me Mickey Mouse, right? Shout out to my friend Lawrence Lessig there. I'm just known as Mickey Mouse, right? And here's the signing key. And over the years, I make a number of really good, well thought out contributions to the project, signed by that digital identity. Now, you don't actually need to know my real identity, but there's a certain level of trust at that point because I've made a number of significant contributions to a well-managed open source project. And at that point, you really open up the possibility of having certain tools or certain services on the internet, on the web, allow me to log in with my hacker reputation, for instance. So if the Git repo maintainers have designations for people who have met some arbitrary threshold of a consistent contributor or whatever, just give me the name contributor, right? Mickey Mouse is a contributor for the Git project, and here's a cryptographic proof of all of Mickey Mouse's contributions that earned them that. So then with that, I could use a URL to the canonical repo and my signing key to create a capability, in a capability security model to authenticate myself to like some open source developer service. Let's say it's a free email service that's only for open source developers that does not screw up patch submission, for instance, right? It's configured so that patches pass through without any mangling. And it's only open to vetted open source developers. You could see that you could use this service or authenticate to this service based on your reputation that's cryptographically verifiable in a repo. So it's the only way I can think of doing trusted anonymous digital identities, because you have to have a proof of work to defeat Sybil attacks. And contributions over time, they're not easy. Getting them landed, like we know this is hard. Getting a patch into any of these open source projects is difficult. And so that would constitute enough of a barrier to prevent people from spinning up random identities and demanding everybody trust them, right? It's just an interesting thing that came out that we noticed that came out of that research. And this project here would start to enable that. We could move into an area where we can have different personas for different projects, for instance. And so there's broader community and societal implications of that.
So we have a minute left, and you just started on a topic that I'm sure we're going to have more discussions about in future meetings. One of the things is just making sure that Mickey Mouse and Daffy Duck like aren't the same person. Like, how do we know if Daffy Duck and Mickey are the same and improving each other's commits? I don't know if that's possible in what you're describing.
Well, I mean, you would just have different signing pairs for them, and they could be the same person. But you can defeat that by doing, social graphs, and there's other science about this. So, I mean,
I think that I'm not aware of any way you can solve that truly just by digital keys. On the other hand, you can allow someone else to sign off and say, "I attest that these two are not the same," and now you're back to, "Do I trust the attester?" Which is in fact a general problem for most of these. That's actually the normal case. How do I know that David Wheeler is David Wheeler? Well, the U.S. government says I am. Well, do you trust the U.S. government? I mean,
You got to
a
trust
lot of
them.
problems. There's an attester you end up trusting.
right. Well, in a Hyperledger, our research basically got us to the point with we don't have to solve the ultimate trust problem. We just have to solve how to bind societal trust infrastructure to the digital trust realm. So a lot of what our work is focused on now is using regulated financial institutions to do KYC attestation, right? And that's good enough for governments. That's good enough for business. That's good enough for trillions of dollars in e-commerce. I think that's good enough, right? So we could, in theory, have a bank, for instance, KYC me, KYC you, Kim, and then without revealing our identities, sign an attestation that my signing keys and your signing keys, I'm Mickey Mouse, you're Daffy Duck, that we are not the same person. That's all that matters, is that this bank is saying we're not the same person. And they could, under court order or something, under a warrant, reveal our identities, but that's not necessary in this, what we're trying to accomplish, which is integrity of an open source project. We're not designing military weapons or protecting, dissidents or anything like that. You have to try to keep things in perspective when we do this. And I mean, I spent 2 years going down all these rabbit holes at Hyperledger, and then we came back to don't let perfect be the enemy of the good.
Yeah.
That's it.
Cool. Well, I got to run, but thank you for the presentation. I think I'd
Sure.
like to follow up and figure out how we can push this along and figure out what's needed. So
Okay.
If we get two things, one is pluggable stuff that you talked about in signatures and ASUN or any other mechanism, and two, a way to get the developer's public keys in the repository itself. Those we will accomplish great things already, because this will allow us to bootstrap trust based on the initial Git clones.
Right. I have a solution for that too. That's also, but it's a 1-2 punch. I don't want to hit the community with both at the same time.
It should be at both at the same time, because that shows why it's necessary and what it accomplishes, I think.
Okay. Well, then I'll fold it in and I'll make it a bigger project.
All right.
Thanks, Constantine, for your time.
yeah, thank you all. Thanks, David, for
Kim, I'll follow up with you from my personal email, so it won't come from Hyperledger or Linux Foundation.
Sounds good.
And David, when it makes sense, if you could just kind of CC me so that I can be aware of what's going on, because I'd like to support this in ways that I can.
Sure. And I would love to do this presentation to anybody else we need to, or attend meetings. And you know what, if I'm lucky, I might find some time to write some code.
Cool. All right.
Cheers.
Thank you guys. Thank you for your time.
Thank
Bye.
you.